Hello dear students, let's see one more example to construct PDA for a given language. Now in this problem we want to construct a pushdown automata for the language a raised to n b raised to 2n, but n should be greater than or equal to 1, n should be at least 1. So just see, the language L can be defined as set of strings that follow this rule. But listen, n should be at least 1. So the smallest string that we will get is a double b. Here n is 1. So obviously if n is 1, a raised to n, then the number of b should be double that of a, because it is said that a raised to n, b raised to 2n is the strings in the language. So if you have 2 a's in the beginning, then there should be 4 b's at the end, and so on. You also observe that epsilon won't be part of this language. The smallest string will be a double b, because n should be at least 1. So you cannot have epsilon empty string in this language. So we want to develop a PDA which will accept all such strings and reject the strings which do not follow this rule, a raised to n, b raised to 2n. So what is the idea? The idea is, given any string, we know that number of b should be double that of number of a's. So what we do is, for every a, whenever our machine will encounter a, for every a we push x 2 times, and for every b, whenever our machine reads a b, we will pop a single x, 1x. So as an example, suppose the input tape is containing 2 a's and 4 b's. You know that this is a valid string because this is a square followed by b raised to 4 and epsilon to follow end of the string. Now we will be using stack in our PDA, where we will say that initial symbol is Z0, correct? You recall that stack is never empty initially. Now we will start reading the first a. When we read first a, when our pushdown automata reads first a, we will push x 2 times. That means we are remembering every a is remembered using 2 symbols, or every a is registered 2 times on the stack. Now the second a also will result in pushing x 2 times. Now as soon as our PDA encounters a b, what our PDA will do is it will cancel 1x, it will pop this. By doing this, we are saying that whenever we encounter a b, we will be removing only x once, but for every a we have pushed x twice. Now you can see that as we encounter b followed by b followed by b, each time we encounter, we will keep on popping, we will keep on removing x from the top of the stack. So what you now observe is, as soon as we reach epsilon, just check, epsilon means end of the string. When we reach this epsilon, the stack is then containing only Z0 on the top. Top of the stack is Z0. That means whatever you pushed, exactly you have popped that much. This proves that number of A's were half the number of B's, or number of B's were double the number of A's. Just as an example, just watch, what if the input string was like this, double A and triple B. Now this is wrong. This is invalid. So PDA should reject such string. What will happen is the stack will contain Z0 initially. For first A, we are going to push x 2 times. For second A, we are again going to push x 2 times. And for each B, we are going to pop x only once. Just check, there are 3 occurrences of B. So we will pop x thrice. Now, as we reach epsilon over here, what's compulsory on reaching an epsilon is that only Z0 should be there on the top. But top of stack at this moment is x. Just check, x is on the top. That means number of b's are not double the number of a's. So this string will be rejected. Okay. So now let's see the development of PDA. Given a string, say double A 4 times B, given this string, what do you expect in the beginning when your PDA starts? What is the symbol you expect? Say it with me. The symbol you expect first time is A, and only A. You cannot have B in the beginning. So you don't define transition for B at all in the initial state. You say when the top of the stack is Z0, at that time, the first symbol should be A. And what you are going to do is keep that Z0 as it is, but push X 2 times. And we will stay in Q0. The idea is that for these A's, we will remain in Q0. We will create a loop. Okay. So now what next we can say? Now, as we read second A, this configuration is not going to work because this configuration says that you are reading a and top is Z0. But now when you will be reading the second A, top will be X. So you will have to define a new configuration. If your PDA reads A and top of the stack is X, then we will restore that X. That X which is on top will be as it is, but on top of that we will push X 2 more times. So the two configurations we have defined is in Q0, if machine reads A and top is Z0. Are you understanding? This is first A because stack is right now Z0. Then we will stay in Z0, but we will push X 2 times on top of Z0. And the second configuration we defined is if in the same state Q0 we are reading A, but top of the stack is X. That means this is not first A, this is consecutive A. Then we will stay in Q0, we will keep that X as it is, but on top of it, we will push X 2 times. So what if now our machine reads a B? In Q0 state, just observe, we are still in Q0 state, machine is reading a B. Good idea is, on reading a B, we will go to a state Q1. Idea is that why don't we ask Q1 to handle this, all Bs? All these occurrences of B, so we can create a loop in Q1. But on reading a B, what do you expect on the top of the stack? Top of the stack has to be X. Come on. You cannot have a B. You cannot have a B without a. So top of the stack has to be X. So you don't define configuration for anything else. You say Q0, if you are reading a B, then top of the stack has to be X. If it is not X, then better halt. Leave the operation, halt and reject the string. Okay, so top of the stack is X, you are reading a B. What are you going to do? You're going to pop once. That means that X is going to be cancelled from the stack and you will enter Q1 state. So what's the new configuration? If Q0 reads B, this is the first B because Q0 is reading a B and top is X, then you change to Q1 state and just remove this X, replace this X with epsilon. Now, what about consecutive B's? What about these B's? What about remaining B's? Yes, if any more B's are encountered, the top has to be X because you have to cancel out an A, isn't it? Then again, you will do the pop operation. So what's the new configuration? If Q1 reads a B, top should be X and you will stay in Q1. You will have a loop, but you will remove that X from the stack. Now, what if your PDA reaches epsilon? If the PDA reaches epsilon, then we will say if Q1 reads epsilon, then top must be Z0. Please try to understand. Stack has to be back to the situation in which it was in the beginning. Whatever you pushed should have been popped. So if you are reading nothing from the input and top is Z0, then good idea is keep that Z0 as Z0. Don't do any change in the stack and go to Q2 state. Q2 is the final state. This is the PDA for the language A raised to n, B raised to 2n. Okay, let's see this in action. So what I will do, I'll just quickly draw the same PDA. Remember, first A, top was Z0, result is XXZ0. Remember, second A or third A or fourth A, consecutive A, top is X, correct? Then result is X pushed 2 times and the top was x and x was pushed 2 times on top of that existing x. First b encountered, top should be x, remove b. We are in Q1. Consecutive b encountered, top has to be x, still x, and remove that x. And now if epsilon is encountered and top is z0, then everything is okay. Keep that z0 as z0 and go to final state. Let's try this with an example. Okay, suppose the input given is a. That's it. Now this is wrong. This should be rejected. Correct? So in which state is our machine? Q0 initially. And what is the stack? Stack is containing Z0. So what is the triplet? You are in Q0, you are reading A and top is Z0. You are in Q0, observe. You are reading A and top is Z0. Then the result is Z0 will be superseded with 2x. This is the result, correct? And you will stay in Q0. Watch. You will have a loop here. So you are still in Q0 and you have gone ahead to read the second A. But you are still in Q0. So what's the configuration? You are in Q0, you are reading A, but top is X. The top symbol of the stack is X. So you are in Q0, just check this. You are reading A, but top is X. But anyway, you got an A, and we said we will push X 2 times on the stack. So this X was restored, but on top there were 2 times X was pushed. And we are still in Q0, you watch, due to this loop. Now you are reading epsilon in Q0. So what's the configuration? You are in Q0, you are reading epsilon, and top, just observe, top is X. What should PDA do? PDA says, I don't know what to do, because such a configuration, just observe, such a configuration is not defined. Do you see Q0 reading epsilon? No, you have Q0 reading A, you have Q0 reading A, you have Q0 reading B, but you don't have Q0 reading epsilon. Then machine halts in Q0 state. But Q0 is non-final state, non-accepting state. As machine has halted in Q0 state, this string is simply rejected. It has not reached the final state. I hope you have understood this. So we have defined transitions only for valid input. If the string is invalid, ultimately such a configuration won't be found and machine will halt in a non-final state. Let's very quickly see for a very small string how the machine reaches final state. Okay, if the input is A double B and epsilon, we start with Q0 and stack, as you all know, is going to be Z0. So the configuration is Q0 is reading A, top is Z0. Yes, you have this configuration here. So we are going to push X 2 times and move ahead in the input, but we will stay in Q0. As you know, we are looping here. Now, what's the configuration? Q0 is reading B and top is X. Q0 is reading a B and top is X. Then we will move to Q1, but we will remove this X, replacing it with epsilon. Correct? Now you see the stack had X 2 times, but now this X has been popped. And we move ahead in the input. But remember, we are in Q1 state now. We have changed the state. And we are reading the next input B. Now what's the configuration? Check that configuration is, we are in Q1 state, we are reading B and top is X. Just check top is X. Then we will loop around again in Q1 and we will pop this X. And we will stay in Q1. Now we are reading epsilon, but we are in Q1. Just observe, we are reading epsilon in Q1. In Q1 state, we are reading epsilon and the top has to be Z0. And note that stack top is Z0. That's good. That means it has tallied what we wanted has been acceptable. This is. Then Z0 can be kept as Z0. We are not changing the stack. Okay, it's okay even if you pop Z0. I mean, instead of this, if you don't like it, you can just change it to epsilon. So Z0 is also popped. But there is no sense in popping that Z0. We can say that we can keep the stack as it is as we started. So the stack is unchanged and we move to final state. Final state has been reached. That means this string is accepted. That's it then. I hope you have understood how to develop PDA for A raised to n, B raised to 2n. Thank you very much.